line, you call this is axis here. On the axis at a distance a by 2, and let this be the center O. So I will construct this as square. So let me take this is A, B, C, D, O. Okay, and this is P. These are distances which are needed for us, and also or later on we'll draw a plane diagram. Now let me take only AB. This is P, this is A, this is B. Convert as a 3D diagram, no? So try to solve this problem in two different planes. It'll be easy for you. Now this will be A by 2, A by 2. And O will not come here. AB wire side. So this distance should be equal to that we have to determine. So call this is R. So these angles will be, let it be alpha, beta. So what to calculate due to one wire? So it is here, that is I. Let's get into the problem. This distance is A by 2, no? This distance is A by 2, and how to get that value of what is R actually? What is R actually R? So I'll introduce one point Q. So that will be inclined here, no? This is what actually R. So you'll get one triangle here. Q, O, this is P. This is A by 2, and this is R. If you want timing, you write it X. Later on, we'll change it. So that'll be easy for you in calculations. So which one is what, that one? Now what is R square equal to? A square by 4 plus X square. So now we know value of R. If you know value of R, can you calculate the field strength at point P due to this? And we don't know alpha. So can we bring the alphas here? Alpha is what? So again for this, we need this length, and R is what? Depends on this one. So let's write all the form. First, what is the field strength at point? Let me write all the equations one by one. So R is equal to A square by 4 plus X square. Then if I know, then I can sine alpha, cos, I think sine alpha, sine beta are needed. Let me take this is S, that one. So what is sine alpha? Sine alpha will be A by 2 and also sine beta. What is S is equal to? S is equal to a square by 4 plus r square. Okay, now further r square you can.
Sir, what is the distance x in this, sir?
X is the AP, no? AP and BP.
They have given a, no, sir.
AP is not equal to A, no?
Okay, okay.
Huh? Yeah. So substitute now value of r square here. Substitute value of r square from here. So you'll get S. The value of S when you substitute, you are going to get the value of sine alpha, sine beta. Then what we get is magnetic field due to wire AB. 4 times of that. There's a magnetic field. But it's asking the net field. How this field should be directed.
Downwards.
So it will make an angle. No? So suppose if you take this is the wire. This one and the point P will come somewhere like this. Huh? I'm asking you, you stand here. You stand here. So this will be the point P. This is R. And this is O. So this should be A by 2. This is X. So how the field due to this should be downward. This is due to AB wire AB. Check it now. So the flip case will come. So you call this as B. Then resultant field has to be calculated. So due to all the wires, again, it will be of similarly downward only. So horizontal components will cancel. Only vertical components will get added up. So call this is theta. If this is theta and B should be perpendicular to R, B should be, so 90 minus theta, this will be theta. I think I've given enough diagrams. 2 mu naught I root 3 pi A. Wait. Some answer, no? Wait, I'll give the value.
C option.
A option, huh?
C.
C will come, huh? Okay, then I'll check once. I'll check and confirm. Somewhere missing, I think. Yeah. 2 mu naught I root 3 pi A. Option C will come. Okay, let me go for calculation one by one. A square, R square will be A square by 4 plus X square. So the value of S will be root of A square by 2 plus X square. So
Sir,
now,
they gave x as a by 2. Sir.
what happened?
They gave x as a by 2 now. Sir.
I'll substitute because all A by 2s will get confused. That's why just in the end I'll make it. In the end we'll make it that one because A by 2 all the confusion will come. That's why I just made that as X. So now you got the value of S. Substitute here, get sine alpha, sine beta. Then again in the formula B equal to this B equal to mu naught I 4 pi R. Can you hear me now?
Yes, sir.
Yes, sir.
Some technical problem came. These are the two rings are there where the plane of the rings are perpendicular to each other. So B bar, so separate them. You do one thing, separate like this. The B bar due to this will be like this, and other due to other ring B bar. So what is the angle between them? 90 degrees. Related, you have to take it. You do have some questions where they'll be inclined at an angle. This is I2. Last problem. Huh? Just see once. Convert, make this problem into, try to view this particular diagram through different planes. View it in different planes. That's all. The only thing is, so now if you see in one side, it'll be like this. No, APB, one triangle, you draw it. And these are the line joining the point P with the ends. It will make an angle with the distance R, perpendicular distance R. So that is what alpha beta, that is what you have to substitute in the formula. This is the one thing. Then again, you look at the triangle QOP, you stand here, and again what when you look at the stand here, and the current will be into the plane, no? Into the plane, and the field produced by this at this particular point P. So we can take approximate rough diagram, like this is one triangle. Then like that open, due to all four sides, the field will make certain angle with vertical, will make some angle theta with vertical. So horizontal components will cancel out. Only vertical components will get added up. So 4b cos theta. What is b? Now due to individual, any one side you take it here. So we don't know R, we don't know S. R you can find out from this triangle, from triangle QOP. So x equal to a by 2 we know, so we'll get R. Then how to calculate alpha beta? Then for that we should know S. So again take help of this triangle. S square equal to a square by 2 R square. Substitute value of R from this triangle. You'll get S. If you know S, then you can bring the cos alpha, cos beta. So sin alpha, sin beta. Substitute them here. You'll get B due to one wire, one side. Then vertical component should, horizontal component will cancel out. Just drawing, trying to view that. Say whenever you get a 3D diagram, what is the best way of analyzing it? View it in through different planes. This is the only thing available for you. So suppose like I think you might have seen advertisement in newspaper. Suppose a car is there. No? How they show? Car is a three-dimensional. They show front part, side part, top part. No, any reason for that? The diagram what happen will give more information for us. So the 3D object what happen, best way of studying 3D object means try to weave it in through different planes. That is the one scientific approach is what is needed. The plane of the loops will make an angle theta, that one. So this is the plane. The planes will make an angle theta. The plane of the loop will make an angle theta here. So there's a loop, you will give the current I1 and I2. Due to I1, it should be B1 bar upward. Now, what about the due to I2? If it were, it will be like this, no? B2, no? Okay, that is same symbols I'll use. It'll be easy for you. This is B2. This is what? B1. Try to look at I made some corrections. Due to only the ring 1, finding difficult, draw individual diagrams. So how the B bar should be upward. This particular ring, the red color ring, so B bar should be in this direction, no? B1 bar. Look at angle between B1 bar and B2 bar. Plane, this is what theta given for us. The angle made by the planes, theta is the angle between the planes of the ring. So where that theta here in the vector diagram of B1 bar, B2 bar, you are going to introduce. This should be theta, no? Or the other angle should be the theta. The angle between them will be 90 plus theta, that one. See, when so you do one thing. For you compare this with this diagram. How much you should rotate the ring I1 so that B1 bar should be horizontal. B1 bar should be horizontal. 90 minus theta. This much of angle you should rotate, no? So therefore, this should be the theta. This should be the 90 minus theta. So this will be theta actually. So angle between them is 180 minus theta. Then write the vector form b1 square plus b2 square plus 2 b1 b2 cos of 180 minus theta and solve the problem. So you should be very careful about the small ideas. These things we are going to use in mutual inductance when we go for EMI chapter. So the resultant B bar, the formula should be b1 square b2 square 2 b1 b2 cos of 180 minus theta. Semicircular wire